Alright guys, in this video we have to find the derivative of the function which actually says that ax plus b whole cube. Okay, so we have to find the derivative of this function, and you can see that there is an exponent in this function, so we can use the binomial expression method to find the derivative of this function by the first principle method. Okay, so first of all we are going to let this function, and then we are going to make our increment. Oh yeah, this x is actually attached to some another variable which is a, right? It is actually a constant. A is a constant, so we have to do the increment in both, right? What I mean to say is, first of all you have to multiply a with the normal variable and then with the increment. All right, so this is this, and now we are going to move this y towards the right hand side of the equation as it is mentioned in the steps of differentiation using the first principle method. Yep. So what it says, if you are unclear about this method, so you can check the playlist in the description, and you can watch all the videos in which I have solved related to the binomial expression method. For now, we have to find the common of this function, right? So this is common, so 1 plus a dot delta x divided by ax plus b whole cube minus 1, right? Now we are going to expand this entire thing using the binomial expression method. So 1 plus 3 dot a dot delta x divided by ax plus b plus 3 minus 1 divided by 2 factorial a dot delta x whole square divided by ax plus b whole square plus dot minus 1, right? So we are going to cancel these two, and now ax plus b whole cube. What is remaining? Yep, you can see that there's a delta x common over here, right? And there's also delta x present in this term. These are actually two separate terms, so I can take out delta x common. But remember, delta x is present over here only one time, right? But over here it is present two times, because a dot delta x is whole to the power 2. Okay, so we are going to take out only one delta x common, because only one is common in both of these terms. Okay, so 3, what remains is ax plus b, ax plus b, okay, plus 3 minus 1 2 divided by 2 factorial. And I won't recommend you to simplify this thing, because this would become 0 at the end of the question. Okay, so a or a square delta x, only one delta x is remain and the rest is taken out. So ax plus b whole square plus dot. Okay, now we are going to move towards the fifth step, which is actually the second last step of solving this question, that you have to take out delta x common. And now we are going to apply a limit of delta x approaches to 0, delta y divided by delta x. Also over here, limit of delta x approaches to 0, and what is remaining? And now wherever there is a delta x, you can put a 0, actual 0 over there. So wherever there's a delta x, only the delta x only exists in this term, right? So this becomes 0, and this entire thing goes out, because this was being multiplied, and 0 multiplied by any number gives the answer 0. So this is the thing which is known to be the derivative of the function the ax plus b whole cube, and you can simplify it further, 3a ax plus b whole cube. And what is this? This is actually ax plus b in the denominator, right? So it is having the power -1, so I can write it like this. And if you see that these two bases are the same, and when the bases are same, the powers are added. This is an identity, iota identity actually, xz. So this is x, y plus z. So what is remaining? 3a ax plus b, 3 plus -1. Okay, the addition is going to happen according to the phenomena, but the -1 is the actual value. So we are going to add it, we are going to add 3 by -1. Okay, so 3a ax plus b, and what is remaining? 3 minus 1 2. So this is the final derivative.